Hi, I'm here with Vishnu from the Eplane company, and we're here to talk about this wonderful piece of technology that they have. It looks like a taxi that flies about, right? Is that what it is?
It is. You got that spot on, right? So fundamentally, I come from the Eplane company. I work with the founder's office. We are building a three-seater aircraft for urban air mobility. Three-seater in the sense one pilot and two passengers. That's the configuration that we're going after. Fundamentally, because the world is constantly moving towards an on-demand service, right? So all of us like the Ubers and the Olas because it shows up whenever you want it to. So we are building for that hypothesis, right? So we want to be able to sort of provide a service for the urban commuter to be able to get from point A to point B. The genesis of the company, we've been around since 2019, and even before that, our founder was trying to sort of work on an application similar to aggregating the operators of helicopters as well as the end user. We realized that helicopters can't scale given the cost structures around how they operate at the moment and also access. Right? So we said we have to look at the platform afresh, and that's when we decided that we will go after eVTOLs. So eVTOLs stand for electric vertical takeoff and landing systems. Helicopters are VTOLs, vertical takeoff and landing, right? So our aircraft takes off like a helicopter and it transitions into a fixed wing forward flight, right? So we've been at it since 2019. We built an extremely tabletop version that we then validated over 7,000 kilometers of flying, right, in total. We then de-risked a lot of the technology going into it. We then put together a subscale aircraft that carries about 50 kgs of payload. We've been flying it for the last year and a half. We've gotten so much data from both these programs that we now have a lot more confidence going into a manned aircraft. We've raised about $20 million to date, and with the last fundraise, we raised about 14 million. That's now fueling our prototyping right now. So we start flying this year, the second half of this year, and that's going to be manned flights. We very recently have been able to attract a lot of talent again within India to sort of put that flight test program together. We have HAL's chief test pilot who very recently joined us, right? So looking forward to this year. It's going to take off quite literally this year, and you'll start seeing commercial operations, small scale by probably end of 26. It's going to be a year and a half between about 3-4 prototypes that will then go in for sort of test flights.
So the 50 kg little prototypes, right?
Yes. Those are now considered to be drones.
Okay. And the passenger drones would have a seating capacity of 2 passengers and one pilot.
That's correct, right? So world over right now, there's no regulator at the moment allows for a fully autonomous flight just as yet. But so you need a pilot on board, right? So which is why we have one pilot on board and passenger configuration. But in the future, there is definitely scope for us to be autonomous, and then it'll just be 3 passengers.
Eventually, what about the infrastructure? Like, where do these drones go, and where do you charge them? Do you have the ports and the infrastructure ready?
Right. For a 3-seater aircraft, we pretty much make one of the world's most compact aircraft. So we'd be able to operate from half a basketball court. Right, we need about 2,500 square feet, including your safety margins to be able to operate. Right? So that way we're infrastructure light. So phase 1 of it will probably start with existing helipads. That's the goal, and then we'll move into other public infrastructure like you have metro stations, you would have bus stations, you have malls, and we're now looking to sort of foster those partnerships. Right, so we're after that, right? In terms of charging, right, so what this aircraft does very uniquely is on a single charge, we can do about 200 kilometers of range on a single charge, right? But we'll never ever fly that much for a single intra-city operation because most trips that you will do is about 20-30 kilometers. Now, given that, we can do about 3 trips before the aircraft needs charging again. So you can now balance how your infrastructure on the ground is deployed. So you can scale a lot more faster with the technology. And that metric is super important for EVs because in electric vehicles, right, the battery is a consumable, which means the more trips you can squeeze into one charge cycle, the lower the unit economics per seat is going to be. So we'd be able to sort of be very competitive in terms of how it's being priced, right? So we are looking at pricing it about 1.5 to maybe 1.8 times the cost of your Uber, right? So it's not going to be expensive. It's for all of us.
That's pretty cool. Pricing seems good. The benefits in terms of time, am I saving any time?
You definitely are.
How
Right? Because
much?
see, in a city like Bangalore or Pune, right? Very recently there was a TomTom report that came out. The average speed in the city is about 9 kilometers per hour. Right? You're looking at 175 here. So there's a direct. In a worst case scenario, you'll probably save about 12x the time. But on average, assuming about 22 kilometers per hour, you'll save about 7x. You're 7x faster using this as a commute form. And you're not necessarily adding more than 1.5 times the cost of your trip either, right? So it's a win-win for both parties.
A minimum of 7x.
A minimum of 7x.
Yeah, I'd go for 3x also. 3x
a minimum
would
of
be good
7x.
enough for
A
me.
minimum of
So,
7x.
yeah, 7x is a definite. Unless the price point is that high, I would really have to think about it. But 7x at 1.8 times the price seems like a good start, a good price point also. When you mentioned 2,500 square feet, So how many drones can you fit in that bay?
So this continues to be an aircraft because it's manned.
Yeah, sorry.
So we will not call it drones. We'll be able to fit one aircraft at 2,500 square feet. That's the smallest landing spot that we would need, right? What that means is in a place like the airport, you would have what we call a verti hub, where you'd be able to handle multiple aircraft. Because one of the first use cases that we've seen emerging quite a bit is the airport transfers, right? From different points in the city, connect you to the airport, right? So in a verti hub, as we call it, right, you'll be able to easily park about 15-20 of these aircraft, and you'll be able to probably take over to work. But in the city, you probably don't want, because see, the larger area that you need within the city, your cost of operation is going to be significantly more expensive, right? Because it's already built infrastructure, it's re-infrastructure in some sense, right? That we don't want to go after that. And plus, these trips in the city are not going to be more than 10-15 minutes, right? The 30-kilometer trip that I told you, if you take 30 kilometers and put in any city, right, the entire urban spectrum is under 30 kilometers, right? Realistically, you'd be able to do anywhere between 15 to 20 kilometers. That's where the customer is, right? Given that the fact that 30 kilometers is going to take you only about 15 minutes, you're not more than 10-15 minutes away from pretty much anywhere in the city, right? Which means you're okay having a smaller spot because you'll be able to manage that a lot more better.
You're saying that, but where exactly is your target market most concentrated at? Is it?
So there are multiple use cases that are emerging right now. The number one use case is obviously on the commute, the passenger commute is going to be airport transfers, right? Second is we're also looking at a lot of people who are daily office commuters, right? Who are trying to get to work and get out of work, right? So that's the second target base, right? We're also looking at some early adopters being the air ambulance use cases. So readily we will be able to offer an air ambulance service, right? So that's something that we're going after as well. So we did a study with Frost about a year back, and Frost puts out that for the Indian market, and we were the first ones to even study the Indian market at all, right? Because the global report spoke about parts of the West, parts of Europe as to what the target market is, but nobody really looked at India as a market. But in the last 9 to 12 months, you've seen the Indian UAM market blow up, right? And that's been our conviction since 2019, since the day we started operating. I still remember having early investor conversations where they said, hey, air taxis even in India doesn't even make sense, right? But today, our conviction has been proven right? Now, given that, at that point of time, there was a potential of about 2 million trips a month for the price point I spoke to you about for the Indian consumer, right? And we did the study across India. So we broke it down into north, south, east, west, and we went to tier 1, tier 2, and we have a social class and all of that. So with that, we were able to sort of get a commitment for about 2 million trips a month. And to serve 2 million trips, you need at least 2 lakh vehicles, right? So the demand in India continues to exist, and that's what's leading some of the global players to come into India today.
What is your aircraft strength like currently?
In strength,
have you all already built
Oh,
models?
yeah. So the subscale has proven the fact that we are capable of putting the aircraft together. So we're also with $20 million, right? We've been able to show you progress that some of the global players have sort of done at about $45-50 million. That's fundamentally because of the staggered approach that we've taken, right? So we've broken down the program into a smaller program where we de-risk the technology in terms of battery packs and propellers, gone into a larger program. So between these programs, there's a lot of learning that's happening, right? That's what's giving us confidence going into a larger aircraft, right? So, given that, we're pretty confident that we would be able to sort of put a product out there very soon, right? And when we started, there was not a lot of regulation here in India, right? So the entire aircraft is designed to European standards in some sense because Europe had a regulation, US had a regulation, right? We benchmarked based on the European parameters, and that's pretty much what India's frameworks also sort of adopted to a large extent, but they've very interestingly put together a bunch of other things as well. We're very impressed with the amount of regulatory push that is there for sort of launching the service. They seem extremely proactive sort of doing this. So much so that they got us to start certifying our propellers ahead of time. So we are now the first and the only company in Southeast Asia to ever put a propeller through certification. All our aircraft propellers have traditionally only come from the Western Europe. Right? We are now going to be the first company doing this setting out of India, right? And that's fundamentally because we need a little more time to get the aircraft out, right? So they said, why don't you get your propeller certified ahead of time? And that's what led us to do it there. And that's what you're seeing, right? And we've got some fantastic results in terms of the propeller, right? Between the design to what we're actually getting results from the wind tunnel, we've been able to get it spot on, right? Our difference between what we've predicted versus what's arrived is less than about 1% or 2%, and that's phenomenal.
What is the USP of these propellers?
Oh, so traditionally these vertical propellers that take you up and these horizontal propellers that push you forward are traditionally have different characteristics, right?
One will give you lift.
One will give you lift vertically up, the other one's pushing you forward, right? They're also designed very differently. But world over, because there are not too many propeller designers, everybody uses the same sort of propellers for horizontal and vertical. For us, that's different. That's directly adding to our efficiency, which is directly contributing to being economical at a unit economics level. Because we have the lowest energy profile per trip for a 30-kilometer trip, and that's what's adding to the unit economics of the whole
What
thing.
is that?
It's called synergistic lift. That's an IP that we filed in about 30 countries right now.
have an IP.
We have an
Oh,
IP.
it's
We've been so at building the aircraft. We have a line of about 25 IPs that we haven't filed yet. That's already sitting on the aircraft, so it's all yet to file. Synergistic lift is the only one that we filed so far, and that's fundamentally around how these vertical propellers are placed around the wings.
It's wonderful. It seems normal aircraft look very different, especially to make them aerodynamic. The structure seems more sleek, and
Absolutely.
this looks very different, but quite unique placement of the propellers as well. A very intriguing structure.
Yeah, right. And this is a full composite structure, right? So the entire aircraft is carbon fiber,
Lightweight.
and we'd be about 2 tons in all of weight, and it's lighter than a 3,000-liter water tank, right? So our end goal is to try and see how to bring it to your terrace, right? Even though we will start.
That would be nice.
Yeah, so the end goal is to bring it to your terrace, right? But not anytime soon, because we have to work with regulators, build confidence in the fact that the technology works.
That will probably take some more time, but
Yeah.
right now I'd settle for the
The
airport
opportunity
trip.
exists. Yes.
But tell me something, in terms of an entire ecosystem, so you'll have the product, you're manufacturing by your end, you probably will roll out, you'll need to 2,500 square feet of space. Do you all have services also that you all are going to provide to, are you going to have operators, liaise with you all, or are you going to take over the entire operations as well?
Right. So in that journey, we are now at that crossroad where we are now forging partnerships with existing operators, but we are also looking at how we can enable them a lot more. And to enable them, we probably will have to run some parts of the service in case we don't find somebody sort of operate in those regions, right? So maybe the Boeings and the Airbus of the world, when they started, they operated an airline for a brief period just to build confidence, right? So fundamentally, we are yet to make that decision, right? Will we operate versus will we find an operator? A lot of interesting operator conversations have now evolved. We're talking to a lot of the existing heli-taxi operators. We're talking to a lot of charter operators, right? The uptake is great there. So we're not sure if we will necessarily operate, but in the event we have to, we will end up doing that as well. Right? So I don't think we will shun away from doing that, because right now, see, building the aircraft is one piece, but sort of having an ecosystem to operate, that is the other. We want to build technology that enables an operator to be able to come in and sort of quickly take it. Right? Very similar to how a Swiggy operates, right? The partner just needs to come into the equation. All he needs is the phone, right? The technology to deliver that, every other support is given by technology. Right? So we want to be able to sort of give them the entire tech stack, but maybe not necessarily operate. We don't know the answer to that question just as yet. It's a decision that we'll get to make.
So you all are open to all kinds of partnerships and collaborations depending on what the client wants.
Scale is what we're going after, because the registered name of the company is UbiFly Technologies. It stands for ubiquitous flying. We want to democratize flying, right? We want to make sure that everybody is able to fly. That's the end goal, right? So whatever it takes to do that, we will do that.
This was a really fun chat that I had. I learned so much from you, Vishnu. Thank you so much for talking to us. And we're really looking forward to
Absolutely. Looking forward to serving you guys soon.
Thank you so much.
Thank you. Thank you
All
so
the
much.
best.
Thank you. Thank you.
All right. Good to see you.
Please, Vishnu.